Hi guys, today let's discuss the LeetCode question 45 jump game 2. You are given a 0 indexed array of integers nums of length n. You are initially positioned at nums of 0. Each element nums of I represent the maximum length of forward jump from index I. In other words, if you are at nums of I, you can jump to any nums of I plus j where this j represents the value of nums of I, and you can only jump till the last index of the nums array, and return the minimum number of jumps to reach the nums of n minus 1. So we have to find the minimum number of jumps to reach the last index of the nums array. The test cases are generated such that you can reach the nums of n minus 1. So which means that we need not write a corner case where if we are not able to reach the last index of that array, nums array, then we'll return minus 1 or something like that. So which means that last index is always reachable. So let's go to the example 1. So example 1 is nums is equal to 2, 3, 1, 1, 4. So in this case, if you take a one step jump from this 0th index, you go to the first index, and from the first index you take 3 jumps, so and then you reach the last position. So which means that we only need 2 jumps to reach the last index. Let's go to the example 2. So even in the example 2 is also quite similar to the example 1. So you take initially we are positioned at the 0th index, we take one step from the 0th index, then we reach the first index, and from the first index we take 3 jumps, and we reach the the last index, which is the 4th index. So the output is 2 in this case as well. Let's go to the constraint section. So in the constraint section, the nums.length is ranging from 1 to 10 to the power of 4, and nums of I, so there are it is ranging from 0 to 1000, and it is guaranteed that you can reach the nums of n minus 1. Yeah, it is already mentioned in the question description part as well. Yeah, I hope it is very clear from this explanation. Let's go into the explanation part of it. Let's consider the nums array to be 2, 3, 1, 1, 4. So the first step that we are going to do is we are making use of a dynamic programming array for this. In this dynamic programming array, I am going to store the minimum number of jumps that is required to reach each index. So for that, I am creating a dynamic programming array. So initially, my dynamic programming array is initialized with infinity for all the values. Since my nums array is of length 5, I am also creating a dynamic programming array of length 5, and I am initializing with infinity. So this infinity means the minimum number of jumps to reach that particular index. So I am initializing with infinity. So the first step that I am going to do now is, so initially my max reach is equal to 0, and I am positioned at 0th index. So we are making 0 for that 0th index. Initially we are positioned at 0th index, so we need 0 steps to reach the 0th index. Then from this 0th index, we have a max reach of 2. So the max reach means from this current index position, since I am positioned at 0, I can reach an index of 2, because nums of 0 is 2, so we can reach an index of 2. So that is the reason I am updating my max reach to 2. Since the max reach is 2, which means that we can reach till this max reach index from this current index position by making a single jump. So I am updating my dp of 1 is updated to 1. Similarly, dp of 2 is also updated to 1. So after completing this updation, I move on to the next index. So I am currently positioned at the first index. So from this first index, my max reach is going to be 4, because max reach is equal to the current index plus the nums of current index. So it is going to be 1 plus nums of 1, that is going to be 4. So my max reach is 4 and I have already performed the updation till the index position of 2. So I only need to perform the updation for the indexes 3 and 4 because the minimum number of jumps to reach the index position 2 is already calculated. So I am only updating for the index position 3 and 4. So in this case, the minimum number of jumps that are needed to reach the index position 3 is equal to 2. How I am getting this 2 is I am positioned at the first index, so the number of jumps required to reach the first index is 1, plus I can take a jump of 2 from that first index and I can reach the third index. So that is the reason I am updating it to 2. Then I also update my dp of 4 to 2. The reason I am updating to 2 is again similar. Since I can reach the index position of 1 with a single jump, and from this index position 1 I can take a jump of 3 units and I can reach the index position 4. So that is the reason I am updating dp of 4 to 2. So once I have completed updating this entire dp array, I need not move on to the next indices because already I am calculating the minimum number of jumps to reach the particular index. So once we reach the end of this dp array, we can safely stop it. So finally we will be returning dp of -1. Yeah, I hope it is very clear from this explanation. Let's quickly code this up. Let's start by initializing max reach to 0. So max reach is equal to 0, and we are going to initialize our dynamic programming array also to float of infinity. Float of infinity. And the length of the dynamic programming array is going to be length of nums. Then we are going to loop through this nums array for I in range of length of nums. In this we are going to update the dynamic programming array. So we'll be using a while loop because we'll be updating for all the values which is greater than max reach and which is less than or equal to I plus nums of I. So when I plus nums of I minus max reach, if it is greater than 0, if max reach plus 1, if it is greater than or if it is okay, we'll make it like equals length of nums. In this case we have reached the end of this dynamic programming array, so we are going to break out of this loop. If it is less than that, we are going to update this dynamic programming array. dp of max reach plus 1 is equal to dp of I plus 1. Then we are going to increment the max reach plus equals 1. And finally we have updated our entire dynamic programming array. So we are going to return dp of -1. I hope we are done. Let's quickly run the code. Infinity is not a valid value for the expected return type integer. Yeah, we forgot one more step. So we will be starting this one with initializing dp of 0 equals 0. This is our starting condition because we will be starting from the 0th index, and the value and the number of steps to reach that 0th index is going to be 0. So we are making dp of 0 equals 0. Yeah, it is accepted. Let's quickly submit it as well. Yeah, it is submitted. Hope you liked the explanation. For more such videos, please subscribe to my channel. Thank you.